So here we are with section formula, right? You've already seen what section formula is for points. So if I had a point x1, y1, z1, and if I had a point x2, y2, z2, right? And there was a point some p which divided it in the ratio m is to n, then what are the coordinates of p? We have already seen this, right? But now we will see the same thing in the vectorial form. So remember, what we saw there is no different from what we are going to see here, but the only thing is that we will see here, we will see everything here vectorially. So for that, what I'll do is I have these points B, A, and C, right? Here, I have 3 points B, C, and A. Whenever C is in between, so for example, I know the coordinates of B, right? The coordinates of B, I know. The coordinates of A, I know. So if I know the coordinates, do I know the position vector? If I know the coordinates of a point, do I know its position vector? The answer is yes. If the coordinates of a point x1, y1, z, if the coordinates of a point are x1, y1, z1, then the position vector of that point is x1i plus y1j plus z1k. We already know this. And what is position vector? Basically, from the origin, you will start and go to that point. If the point P has coordinates x1, y1, z1, you will start from the origin, go to that point, and this vector OP is basically this, right? And that OP vector is the position vector. So I know the position vector of B, I know the position vector of A, but what I don't know is C. Remember, if C is in between, so as you can see here, C is in between, then it's called internal division, right? Whenever your unknown point is between the 2 points, it's called internal division. Whenever your point C is outside, right, it's outside, B and A are here and C is not in between B and A, C is outside. So that is called as external division. So we will see the formula pertaining to both. Now as you can see here, this particular line BCA is being divided in the ratio n is to m by the point C. That means I can say that AC bar by CB bar is equals to m by n. Can you justify this? Can you justify this? What is the vector AC bar? AC bar is this vector, right? Let me just show you. AC bar is this vector which starts from A, goes to C, right? And what is CB bar? CB bar is the vector which starts from C and goes to B. Now both these arrows are in the same direction, right? The only thing different about this arrow and this arrow is the magnitude. So if I take the ratio of the vectors, that is nothing but the ratio of the magnitudes. And the ratio of the magnitudes is the ratio in which it is being divided, right? M is to n. If m is huge, if this m is huge, that means this pink line will have a greater length, and that will be reflected here in this ratio, right? So with this ratio, we can actually proceed. AC bar into n is equals to CB bar into m. Now, AC bar can be written as OC bar minus OA bar. We have already seen this in the previous video. This is nothing but vector joining 2 points. If you can imagine your origin here, this will be your OB bar, which is your small b bar. This will be your OC bar, which is your small c bar. Let me use a different color for this. So, from the origin, the vector that goes to B is b bar. From the origin, the vector that goes to C is your c bar. And from the origin, the vector that goes to A is your small a bar, right? And these three, this B, this C, and this A, these small A, B, C's are your position vectors, right? And if you want the vector joining 2 points here, AC bar, right? A and C, you want the vector joining A and C. That is nothing but OC bar minus OA bar. This is something that we have already seen. Now coming to the second part, CB bar. CB bar is nothing but OB bar minus OC bar. So if you're going from C to B, you will write OB first and then you will write C. We've already seen this. This is M, right? Now, OC bar is nothing but your small c bar, right? This, as you can see here, OC bar is nothing but this small c bar. Similarly, OB bar is nothing but small b bar, and OA bar, this is your O, right? This is your O. OA bar is nothing but small a bar. So I can replace this, all these quantities here. I can write OA bar as small a bar into n. I can replace OB bar with small b bar, OC bar with small c bar into m. Now what I need is, I need to collect the coefficients of c. So let me just take this equation here. So it will be, if I just expand this will be nc bar minus na bar is equals to mb bar minus mc bar. I'll take the c components common, rearranging them, n plus m into c bar is equals to na bar plus mb bar. And c bar will have the coordinates mb bar plus na bar by n plus m. And this is nothing different. This is very similar. This is very similar to the formula. This is very similar to the formula that you get from here, right? From these points. What was the formula for p? If you need the coordinates of p, what you will do is you will take m, multiply that with x2. You will take n, multiply that with x1 and add it, divided by m plus n. And this is the x coordinate of p. Similarly, y coordinate will be like this. And z coordinate will be something similar, right? So as you can see, this m into some quantity of this, n into some quantity of this. Similarly here, n into the vector a bar. So this is your n, but your a bar is here. So something like n into the vector a bar. Similarly, m into the vector b bar, very similar. Just that instead of using coordinates here, instead of using these three coordinates, I am using the vectorial form, right? I am using the vectorial form and there is no other difference. mb bar, and what do I mean by vectorial form? Instead of using coordinates, I am using position vectors. So instead of using x1, y1, z1, I am just using x1i, y1j, z1k. I am using position vectors. Whenever you do that, whenever instead of using coordinates you use position vectors, that means you are using the vectorial form, right? That's all it is. So this is the formula for section. This is a sectional formula for internal division. What about external division? I won't be deriving it separately, but as I already showed you in coordinate system, you replace n with minus n. You replace n with minus n or m with minus m. Any one of them. Any one of them you will just replace with its negative. So I'll choose to replace n with minus n. So now if I need c, which lies outside the line joining AB, c bar will be like, it will be mb bar, but instead of an n, I'll now have minus n, a bar divided by n, instead of n, I'm using minus n, right? So I can write this m minus n. This is the formula for external division. What you can also do is you can also replace m with minus m. So I have replaced n with minus n. You can also replace m with minus m, and that will also give the same result. You can check that for yourself. With this, we complete the sectional formula section. Let's move on to the next subtopic.